hopefully by the end of today, you are good at these two goals. So we've already done finding and using inverse trig functions, so solving them. So remember yesterday we got through those two. Today we're finding and using derivative and the integral of the inverse functions. So these three, okay? I've copied the rules. 6 rules are the main ones we're using today. What do you think the a value is? X over a. Okay. So if you go back to here, 2x. So 2x is the same as x over a half. X is the same as x. Yep, very good. So the a value is a half. Okay. So we just substitute into, we just use the rule, sorry. So remember I said it's a -1 on the top for cos, or arccos I should say. We then have a squared minus x squared. So let's see if I got it right. A squared minus x squared. Okay? Quarter minus x squared. Do you think I'm finished yet? What are your thoughts? We could make the denominators the same for inside this square root. Right, so I've made the denominators the same. Now the reason I did this is because I am going to be able to factorize. Okay, and the reason I am factorizing is because this is a squared number. So I'm going to be able to bring that outside of the square root. So if I bring a quarter out, it becomes a half, right? And if we divide by a half, it becomes a whole number up the top, like that. So I brought the quarter outside the square root, and I then flipped the fraction because I'm dividing by a fraction. You flip the fraction. Number at the top is positive, and there is a square root. So positive square root is that one. Okay? Now if we have a constant in an integral, what can we do with a constant? A becomes, bring that out the front, we've got 1 over square root 25 minus y squared dy. Okay? Now we've got a number minus y squared. So what's the a value for the... Yeah, well done, 5. So you do the square root of that number to get the a value. So now we can integrate 8. So we have sine, or arcsin I should say, x, whoops, there's no x, this is dy, so we've got a y over 5 plus c. And that's it, because it's not x by itself like in the rule. So what we can do, let u equal 2x, right? And then remember we do the derivative. So that's 2. So like before, step 1, let u equal to the thing squared. Step 2, the thing squared. Step 2, find the derivative. Step 3, isolate dx. Because we're going to substitute that back in, like we have done the last couple of lessons. Okay, so if you have a look at this, we're going to bring the constant out the front. We are then going to sub in this one. So instead of 2x squared, I think I made a mistake. I think that should be a square root. So u squared is 2x squared. Yeah, sorry, I made a mistake. Okay? And then, what am I doing? Oh yes, so then I put the u squared, so I'm substituting square root 2x equals u, so that's u squared. And then I'm changing the dx, so it's du. So I'm getting rid of all of the x's, because when I integrate, I don't want any x's in there. You could even bring this constant out the front as well. So it would be 4 over square root 2. We'll worry about getting rid of that third later. So now we've just got this bit being integrated here. So this becomes arccos u divided by the a value, which is 3. Okay, plus substitute back in, substitute these two in. Step 5, integrate, and then we sub back in. So you could get rid of the third, so multiply the top and bottom by square root 2, and that becomes 2 square root 2, cos, change the u to square root 2x over 3 plus c. And that's it. So a little bit of surd stuff happening there.